similar triangles, and trigonometry. In this unit, we'll look at the review of some angle theorems that you've learned. Then we'll get into similar triangles. Then we'll look at some right-angle trigonometry. We'll get into primary trigonometric ratios, and then we'll look at sine law and cosine law. The second sheet here has all the formulas that we'll be using in this unit. So let's review a few things that you should know from previous math classes. So some basic rules. If you have a straight line here, so here we have a straight line, we have an angle x and an angle of 55 degrees, and it's being split by this line right here. We would know that the sum of this should equal 180. So we would know that x plus 55 equals 180. So if you bring 55 to the other side, we see that x is 125 degrees. Similarly, if we have a point here, which is met by three different lines, the sum of those three angles must add up to 360 because a full rotation is 360. So we have y plus y plus 92 plus 151 should equal 360. And if you collect 92 and 151 together, we get 243. We bring this to the other side by subtracting, and we get y equals 117 degrees. Vertically opposite angles are equal. So here, if you have two lines that meet, so if you have a line that meets like this, we would know that this angle equals this angle. If we have two very narrow, this angle would equal this angle. So opposite angles are always equal. Similarly, in these pictures, this angle right here would be equal to this angle right there. And this would be equal to that. So if this is 63 degrees here, then Z is also 63 degrees. We've learned before that the angles in a triangle need to add up to 180 degrees. So in this triangle, we have A, so this angle right here, A plus 47 plus 52 should add up to 180. Similarly, we can add these two together to get 99. Bring the 99 to the other side by subtracting it, and we find out that A is 81 degrees. And then we have angle sum of a quadrilateral. So in a quadrilateral, the angles will add up to 360 degrees. So we can follow that same concept as with triangles, just add them up to get 360. Okay, angles and parallel lines. So we're going to focus in on this one a little bit more here. So if you have two parallel lines, and that's notated with these arrows here, showing that they are parallel, meaning they will never meet, and you have a line called a transversal, which is this red line, we have three different concepts that flow out of this. So one of them you may have heard is called alternate angles are equal, and we commonly call it the Z pattern. So you can see the Z pattern right here, at the inside angle right there, they are equal. We have the F pattern. So if you draw an F right here, then we would know that this green highlighted spot is equal to this green highlighted spot. This is called the corresponding angles. And then the interior angles, the last one here, or the C pattern, is a little different, so we've got to be careful about this one. This does not tell you that the blue angle there is equal to the green angle. It tells you that it adds to 180 degrees. So to look at an example here, if you have an angle of 70 degrees, and then you have some angle down here, notice that we have the transversal, we have the parallel lines, then our Z pattern on this one, so if we draw a Z right here, we can see that these two angles are equal. So C equals 70 degrees. And this is called the alternate angles. Here again, we have the transversal. We have two parallel lines. This time we can draw a C pattern, and we can get that this angle plus this angle, so that the interior angles, they should add up to 180. So we know that D plus 75 should equal 180. If we subtract 75 from both sides, so that this crosses out, we have D equals 105 degrees. Lastly, we have a corresponding angle situation here. So again, a transversal, two parallel lines, so we can use this theory. And we have a backwards f. So you got to flip this backwards, and we can see that 72 degrees here is equal to that one right there, which is 72 degrees. To put this all together in a bit of a picture here, if this is 72 degrees, then we know that this angle must be the other portion that adds up to 180. So 180 minus 72 would be 108 degrees. So that would be 108 degrees. This angle right here should be equal to this one because they're opposite angles. So this one would be 72 degrees. And this one right here would be equal to the red. So that one's 108 degrees. We can keep going all day here. So we already said that E is 72 degrees because of the F pattern, which means that this is 72 degrees. And then we have these spots right here. Again, they're going to, the 72 plus whatever it is needs to add up to 180. So this would be 108 degrees and 108 degrees. There you go. We have all those angles labeled in that picture. So here you can see, if you turn your head clockwise and look at this, we can see that this angle right here, again, we have parallel lines, so we know we can do this idea. So this is the F pattern. So this should also be 28 degrees. And we know that M plus N here needs to equal 180 because it's part of this line right here where it needs to add up to 180. So we can subtract off M from 180 and we can get N equals 152. All right, I'm going to skip over that little section there. So let's just do a couple quick examples here without any answers in front of us. So if we have a point here and three lines meeting up to it, we know that the sum equals 360 degrees because that's a full rotation. So we know that B plus 41 plus 296 should equal 360. If we collect these two together, we get B plus, and we have 41 plus 296, which equals 337 equals 360. And we want to get B by itself, so we'll subtract 337 from both sides. And we get that B equals 23 degrees. Okay. Let's look at number 2 here. So notice we have parallel lines right here. And we don't, by the way, notice that we don't know these two lines right here. We don't know if they're parallel. Okay. So these arrows indicate that they go on forever. They do not indicate that this is parallel to that. Okay, so we don't know that. In fact, in my diagram, I'm not sure. I don't think it is. But we can tell by these right here that these are parallel. So this is the parallel. This would be called the transversal right there. Let me put it in red like in those other diagrams. So there we go. There's our transversal, which would tell us that if I draw a Z pattern right here, that these two angles should be equal. So we know that B equals 80 degrees. I will leave questions numbers 3 to 10 for you to work out. But let's do one more concept for today. So this is solving proportions. So let's say we have something like x over 2 equals 3 over 5. We can do something called cross multiplication in this situation. So cross multiplication, be careful, is only done when we have an equal sign between two fractions. So it's two fractions on either side, and we get to cross multiply. So if you remember this method, we take the x and multiply it by the 5. So we get 5x equals, and then over here we get 2 times 3, which equals 6. That gives us 5x over 6. So if we're trying to get x by itself, which is usually our goal, to get letters by itself so we can solve for them, we're going to divide 5 out of both sides, which crosses that out and leaves us with x equals 6 over 5. And that is a perfectly accurate answer. Let's try the same concept here. I'm going to move this one over a little bit. So if we have 2 over x equals 1 over x plus 1, we're going to take these two parts here and we're going to multiply it. So it's 2 times x plus 1 because we're multiplying 2 by the whole bottom there. Similarly, we take x and we multiply it by 1. So what does that give us? So if we expand here, we get 2 times x and 2 times 1, which is 2x plus 2. And on the right side, we have x times 1. So x, anything times 1 is just itself. So we have x. All right, let's bring the x's to one side. So I'm going to subtract x from both sides. So that leaves me with 0 on the right side. And if you have 2x and you minus x from it, collecting like variables there, we have x left, plus this 2 still. Lastly, I'm trying to get x by itself, so I subtract 2 from both sides. And now I have x equals, this negative 2 and positive 2 cross out, and we have negative 2. So x equals negative 2. Just as a little reminder, whenever you find a solution, you can check your answer. So let's just check it for fun. So what you do is you go back to the original question and you plug in negative 2 for x. We got 1 over, and we got negative 2 plus 1. So how do we check it? Well, we just do the math associated with it. What's 2 divided by negative 2? That is negative 1. And what's 1 over? What's negative 2 plus 1? That's negative 1. So that leaves us still with negative 1 on the left side, and on the right side, if you do 1 divided by negative 1, you have negative 1. And this is a true statement, which means you did in fact solve the problem. And there you go, that's how you solve a proportion.